Hello everyone, and welcome to the Modern Java course. In this video, we're continuing our coverage of baseline features from Java 8, specifically default methods and streams. Up until Java 8, interfaces could only have abstract methods. This created a problem. Let's say I want to add a method to an interface, but some person has already implemented that interface. Their code will no longer compile. Surprisingly, it would run and work if you don't invoke the missing method, but that was inconvenient and created a disincentive to using interfaces. Developers ended up using single method interfaces and creating multiple separate interfaces just to avoid that problem. Java 8 solved this by introducing default methods. We can add non-abstract methods to an interface. Such methods don't do much. They can't modify fields because the fields are all final. But it is a powerful tool, as you can see in this code. Notice that static methods in interfaces were also included in this change and are now legal. This is an important feature since it lets us evolve interfaces with new features without breaking compatibility. That's how Java was able to add streams and change the collection API to support them. Java 8 introduced several functional programming concepts. The most important of them was streams. The word stream is used for two separate features in Java. One is the context of I/O, to read or write from a file or network. Another case, which is the one we are discussing now, is for streams of data, which means lists or collections. The stream API lets us process elements in a functional style, which is more fluid than using the traditional for loop. In this example, numbers is a list containing random integer objects. The stream method converts the list to a functional interface that lets us chain independent operations. Every operation transforms the list in a small way. The filter method accepts a predicate interface, which is expressed as a lambda here. The argument is the entry we are currently filtering. In this case, we are filtering out all negative and uneven numbers. The distinct method removes the duplicates, and the sorted method sorts the stream. This shows the greatest asset of streams. The functional structure is almost self-documenting. The collect method converts the result back to the collection, in this case, a list. The stream code can be further refined by removing the lambda expression from the filter and replacing it with a Java 8 method reference, as you can see here. We can do the same thing using a for loop, as shown here. A set allows only one instance per object. Tree set is sorted, so we do not need to sort at the end. This only leaves the loop and numbers, which is simple if statement. So which code is better? While this code is a bit shorter, I'm not sure if it conveys the intention with the same elegance as a stream. Most examples argue that the stream approach is better because it expresses the intention of the programmer. This is open to debate. There is an argument to be made for loops too. At the time of this writing, loops are typically faster for smaller and simple cases, while streams have an advantage for huge sizes. With the previous code processing 100,000 numbers on a Mac, it took 20 milliseconds for the stream and 14 for the loop. Raising that number to 10 million changes the picture. Streams take 1,352 milliseconds and the loop 2,159 milliseconds. The performance story is not clear in this case and is continuously evolving. In a for loop, we can modify a class member as we loop. It's not a problem in theory, although it might complicate matters. Imagine two threads hitting the for loop. You would have a mess. So we use synchronization and open a new can of worms. In streams, we should strive to avoid side effects. A lambda or method reference invoked by a stream shouldn't read or write to a variable that wasn't passed through the stream. Unfortunately, due to the way Java was built, this can't be enforced by the compiler or API. If there are side effects to a stream, it will limit some of the more extreme capabilities. Without side effects, you can debug streams via peak operation, you can use the stream debugger built into IntelliJ, or you can use a parallel stream to process multiple values concurrently. There's a lot more to say about streams, and I might revisit them in the future if there's demand for that. I think we had enough of a Java 8 recap. In the next video, we'll discuss Project Jigsaw, the Java module system, one of the biggest changes to Java ever, and one of the most controversial changes. Follow through the videos to check the full course. If you have any questions, please use the comments section. Thank you.